Hello everyone. Today we are going to explore one of the most fascinating problems in complex analysis, evaluating the exertion all-powered I. This may look like something pure imaginary, but the result will surprise you. Our problem is simple to state, but deep in meaning. What is the value of I powered I, where I is the square root of -1? This is a classic problem that demonstrates the beauty and power of the complex analysis. The key insight of the problem is that we mean z equals to I power r. For complex exponentiation, we know that a to the power b is equal to e power to the power of b multiply ln a. Well, ln is the complex logarithm. So we can write the z equals to e power to the power of I multiplied as an r. This is a complex logarithm is the key of this problem. And we can write the logarithm ln I equal to ln absolute value of I plus I multiply arc of I plus 2 pi n. For I, absolute value of I is equal to 1 and arc I is equal to pi divided by 2. So ln I equal to ln 1 plus I multiply pi divided by 2 plus 2 pi n. So we can write ln I equal to I multiply 2n plus 1 divided by 2 multiply pi, and is integer values. Logarithm is multi-value in this relation. So we can write I to the power of I equals to e to the power of I multiply ln I. After the substitution, I to the power of I equals to e power to the power of I multiply 2 and plus 1 divided by 2 multiply pi. So after the simplification, we have e to the power of I2 multiply 2 and plus 1 divided by 2 multiply pi. We know that the I to the power of 2 is equal to -1. So I to the power of I is equal to e to the power of -2 and plus y divided by 2 multiply pi. So we can write I to the power of I is equal to e to the power of -2 and plus 1 divided by 2 multiply pi. We can see that the result is a real value. R to the power of I is real for all branches. So for principal value, we take m equals to 0. So I to the power of I is equal e to the power of minus b divided by 2. Numerically, we can calculate that e to the power of minus p divided by 2 approximately equals to e minus 1.5708. And all power o to the I to the power of I approximately equals to 0.20787995763. This is a real number. Imaginary base and imaginary exponent generates a real result. And this is the secret. This is the main result of this video. All possible value for all integer ends, we have I power to the power of I is equal to e to the power of minus 2n plus 1 divided by 2 multiply pi. For different value of it, the I to the power of I has been calculated here. For 0, the I power of I is equal to e power to the power of minus b divided by 2. For n equals to 1, the I to the power of I is equal to e to the power of minus 5 divided by 2. For n minus 1, I to the power of I is equal to e to the power of 3 pi divided by 2. For n equals to 2, the I to the power of I equals to e to the power of minus 9p divided by 2. And for n minus 2, I to the power of I is equal to e to the power of 7 pi divided by 2. Infinite manual value all positive. And although it has some properties, why this value is real? I power to the power of I is equal to e to the power of I ln I is equal to the e to the power of I multiply pi divided by 2 is equal to e to the power of minus pi divided by 2. The imaginary unit is in the exponent, cancel imaginary unit in the base. Also, there are interesting facts. I to the power of I is real and positive. The principal value is about 0.2078. Our branch are positive about real numbers. This is one of the most famous identity in complex analysis. The complex or looking expression that simplifies it beautifully. Although here we have some comparisons with other powers. For the expression I power 1, the value is 8. I power 2, the value is -1. I power 3, the value is minus I. I to the power of 4, the value is 1. All I to the power of I, the value is e to the power of minus p divided by 2. Minus I to the power of I, the value is e to the power of pi divided by 2. And so on. Minus I power to the minus I is equal, the value is e to the power of minus pi divided by 2. Okay, and final answer about the evaluation of I to the power of I. Using the complex logarithm, we have I to the power of I is equal to e to the power of minus 2n plus 1 divided by 2 multiplied pi. And final answer, we have this for n equals to 0. Final answer, I to the power of I is equal to e to the power of minus pi divided by 2. Real number from imaginary components. Thanks for watching. See you in next video.